to our dear lecturer Dr. Rosmizi and fellow friends. I'm Tanya Sri Ramalingam from Group 20 gonna explain regarding what does distributed energy resources means. Distributed energy resources, also known as DER, is often referred to smaller generation units that are located on the consumer's side of the meter. Distributed energy resources have changed the power generation sector, distributing traditional markets and distribution models. Those working in the field tell power that research and development will continue as a part of the evolving landscape for solar, wind, battery storage, and other energy technologies in a changing regulatory environment. Examples of distributed energy resources that can be installed include rooftop solar, photovoltaic units, wind generation storage, and battery storage.
Hello everyone, I'm Swati Sydney Soren here. My metric number is 2210311626. In the previous video, my groupmate Tanya Sri gave a sweet talk about introduction of distributed energy resources, and in this video I'm going to explain about the basic principle of distributed energy resources. Distributed energy refers to creating and storing energy somewhere near the point at which it will be used rather than generating and transporting it from a far off location. In a principle, distributed energy can come from almost any fuel source including fossil fuels, solar panels and backup generators. In addition, there are primary energy sources that may be taken from any form, including nuclear energy like oil, coal and natural gas, and renewable sources like wind, solar, geothermal and hydropower.
Hello everyone, now I'm gonna explain regarding the problem that will be faced in distributed energy resources. The problem that distributed energy resources will face are the threat to utilities from reduction in revenue as the amount of electricity generated by power plants lessens, while the plants operating utilities still must invest in the infrastructure to maintain the grid. To overcome these issues in the report I have mentioned regarding making sense of solar, advancing energy storage and helping utilities take on new challenges. But here I'm going to explain regarding about wind turbines are changing the energy landscape. People across the US have installed wind turbines for residential use, often in rural areas, to power farming operations. Utility companies also have ramped up their generation of wind power. The American Wind Energy Association says the US had nearly 85 gigawatts of installed wind power generation capacity at the end of 3Q 2017, with more than 52,000 utility-scale wind turbines in operation. Texas leads the nation with nearly 22 gigawatts of installed wind power generation capacity and more than 12,000 operating wind turbines according to AWEA. This will bring benefits to DER. The benefits include cost saving to customers, a reduction in the emissions, the move away from fossil fuel generated power, and more control by consumers of their own power. Companies are finding opportunities to invest not only in generation such as solar and wind, but also in areas such as battery storage, software, market designs, operations, oversight, and more. And utilities are looking at ways to capture those opportunities with their own products and service. Part of the challenge of offsetting lost revenue from lower electricity prices and changing market structures as they look up to recoup the cost they incur from wider development of DER technologies.
Continuously, in this video I'm going to explain about how the distributed energy resources impact our economy. Various RES can be used to generate electricity in residential and industrial areas using cost-effective technology. So the main impact of DERs are by the saving of fuel, transmission, and distribution of costs and reduction of the price of electricity. Some more, DER also provide energy value when they display the need to produce energy from other resources. That value has two parts, which are awaited energy production by generation resources, and another one is awaited line losses on the transmission and distribution system.
Good morning. So my name is Tanis Raj. My metric number is 122103235. So today I would like to talk about the advantage and disadvantage of DER. So the first thing is advantage. So when we're using about the DER distribution electric resources, they can provide positive net value to the electricity grid. The second one will be they provide energy value when they displace the need to produce energy from other resources. They also have the capability of the when the absence of line losses in turn lower the cost of energy for your company. It really deep down lower your cost of the company when you uses the DER. The last one will be the DER provide distribution level capacity value when they differs or avoid investment in distribution assets. The distribution capacity value of DERs depends on the DER's utilization capability during local peak periods. So these are the advantage of using DER. When it comes to disadvantages, the first one will be when we're using the wind turbine or solar panels like that, it depends on the weather condition, which can be a source of power. So when there is no source of the power, like for example there is no wind or the sun never come like that, which means the DER will be in suffer. The second one will be the grid infrastructure was primarily designed for centralized power generation and integration numerous DERs, each with varying capacity and location, requires significant upgrades and modification. This modification requires a lot of works and expensive, so which means that this cost will be very much above. Okay, so the third one will be the DER type typically have limited capacity compared to large centralized power plants, while they can contribute significantly to the local power supply. So these are the advantage and disadvantage of the using DER. That's all. Thank you.
Good afternoon. My name is Sivaganesh Chaladurai. My metric number is 221031625. Today I want to explain about operation and application of the distribute energy resources. First of all, operation of DERs. DERs can operate in the gate connection of off-grid mode. The grid connected DER can either export excess energy to the grid, import energy from the grid when needed. DER can be remotely controlled to optimize their performance and integrate with the overall grid system. That is the smart grid of the images. Microgrids are located the power system that can operate independently from the main grid or in conjunction with it. They consist of the multiple DERs such as solar PV, wind turbine, energy storage. Along with the control system and distribution infrastructure, microgrid can be developed in remote access. The next, going to explain about the application of DERs. DERs can be implemented at different scales, from individual homes to entire communicate. DER can be used for variety of purpose, including generating electrical for local consumption, providing backup power during outages, reducing peak electric demand, balancing the grid by providing NCT service. DER, especially microgrid and energy storage system, exchange grid resilience by providing backup power during grid outages or emergencies. DER can also combine with the energy storage to provide ever greater flexible and resilience. The next part I would like to explain effect to environment and society of distributed energy resources. First, environment effect. Reduce greenhouse emissions. These such as a solar photovoltaic PV system, wind turbine, biomass generator, produce energy with much lower carbon emissions than traditional fossil-fueled power station. This led to reduction in greenhouse gas emission, which help to mitigate climate change. The next, reduce air pollution. Unlike traditional power plants that release pollutants like sulfur dioxide, nitrogen oxide, many do provide a clean energy without any emissions. This helps to reduce air pollution, which can lower an incidence of respiratory disease. Reduce water consumes. Traditional power plants consume the significant quantities of water, mainly for cooling purposes. In contrast, most did operate without the need for water. This can help to conserve the water resources. Next we see about societal effect. Increase the energy independent. DERE can help individuals communicate to become less reliant to centralized power plant and energy companies. This gives more control over their energy uses, reduces the exposure to electricity, improve the electricity price fluctuation and supply distribution, and improve the energy access. DERE can help to provide electricity to areas that are not connected to the grid. And job creation. DERE require the installation, maintenance, monitor, which create the job local communicates. And last one is exchange resilience. DERE can improve the resilience of the power system by reducing the impact of the power outages and increasing the ability to recover from disasters like hurricanes and earthquakes. That's all. Thank you.
Distributed energy describes the vast array of small-scale energy technologies owned by consumers like rooftop solar, home batteries, electric cars and their charging points, and smart appliances like heating, cooling or pool pumps that can talk to each other and respond to signals from the grid. A quiet energy revolution is taking place as more and more Australians invest in these technologies. Rooftop solar, home batteries and other innovations are putting power into the hands of consumers. Today, more than 1.8 million Australian households already have solar panels on their roofs. Tens of thousands of Australians are installing home batteries in their homes to store electricity and provide backup power. Soon, more and more people will also have electric cars, smart appliances and home energy management systems that can coordinate and control our energy use. As all of this technology gets cheaper and more efficient, this is only expected to grow. Individually, this reduces household power bills, but collectively, it's transforming the energy system. By 2050, 45% of our electricity is expected to be generated from distributed energy like rooftop solar. Households and businesses are less reliant on big power stations than ever before. That creates lots of challenges for the current system to overcome, like how to manage the voltage or how to predict supply and demand. That's why at ARENA we are supporting the innovations to harness these resources like virtual power plants. If we can make these resources work together, it can make the electricity network stronger and more affordable. As well as being renewable, Australia's future energy generation will be small scale and highly distributed.